Thanks for sticking in there. We got one more video on this review, EOC review number 4. Once again, that link is updated in the, it should be in the link on the description below. This is part 3, adding, subtracting rational expressions and solving equations involving rational expressions. Once again, we'll utilize as much technology resources as we can that I have up my sleeve. Here are some tips and tricks. I'm not going to read these to you, but you can certainly pause this and write those down if that would apply to you to help you understand any of the stuff that we're going to do in the next couple of problems. Let's get started. First question, what are the values of A, B, and C that make this equation true? Now, this looks like an equation, but it really is just saying, hey, add those together and tell me what you get when you simplify it. So what I want to do is I want to kind of rewrite this. I'm going to write 2x plus 1. Go ahead and save the time there. So 2x plus 1 over x minus 4 plus x minus 3 over x plus 5. Notice I left a lot of space on there. I'd advise you to do the same. What we're going to do then is we're going to make sure everything gets wrapped around in parentheses. These are all individual factors, and so they're going to get their own groupings. From there, in order to add, we have to have common denominators. So we have to steal the denominator from each fraction and bring it over to the other side. But what we write on the bottom must get written on the top. So you want to copy denominators on top on the numerator and then work the numerator out. That's going to look like this. We're going to have this x plus 5 that's going to get written next to the x minus 4. But we're also going to write it next to the 2x plus 1. Over here, we're going to have the x minus 4. That'll get stolen from this denominator, and we're going to copy it on the top. And the reason why we want to copy it is because we want to have an equivalent expression. And by multiplying something over something, it's basically multiplying it by 1. It doesn't change the value of the expression, but it allows us to add the numerators together. So this expression, before I simplify it, would look like 2x plus 1 times x plus 5 plus x minus 3 times x minus 4. And we just write it over our denominator one time. So that's going to look like x minus 4 parentheses x plus 5. So what we really want to do is we want to get this simplified and find an expression that's just 3 terms. So we're going to do that by, I'll just use the FOIL method. I'm not going to bother with a box, but this is distributing. So this is going to be 2x times x. That's 2x squared. We got 2x times 5, so that's plus 10x. Then I'm going to go here and distribute the 1, so plus 1x. And 1 times 5 is plus 5. I would do the same thing for the other set of parentheses, so that's going to be x squared. We got x times negative 4. We got negative 3 times x. And finally, we have negative 3 times negative 4, which is positive 12. That's all written over your denominator. I'm not multiplying my denominator out, so I'm going to leave x minus 4, x plus 5 as is. But now I can combine like terms. So I want to combine my like terms on the top, and let's see what we get. So we got, let's see, we got a couple of x squareds, 2x squared and x squared. That's going to give me 3x squared. All right, we got a whole bunch of x's. So let's see, we got 10x, 1x, that's 11x. 11 minus 4 is 7. Minus 3 is 4. So that should be 10, 11, 10, 9, 8, 7, 6, 5, 4x. So let's write that as 4x. You can double check my work in a calculator. And then my last number is 5 plus 12. I know that's going to be 17, but let's go ahead and be consistent with my notation. So positive 5, positive 12, that's going to give me positive 17. And that just gets written over your denominator, so over x minus 4, x plus 5. That's my final answer. But the question doesn't ask you for the final answer. It asks what values of A, B, and C make this true. This would be like a drag and drop on the EOC. And you can't get away with just graphing it because you don't have all the answer choices, or there's going to be way too many for you to even try to plug them all in. So I know that A is this value. That's going to be your A. So A is going to be 3. I know that B is positive 4, since that's a plus 4. So B is 4. And I know that C, that constant number, is positive 17. So C is 17. And now I have all 3 of my constants, or my coefficients. That is how you do that question. 3, 4, and 17 are your answers. All right, write that down, pause the video if you need to, and let's go to the next question. All right, let's talk equations. Solve the following equation for all real solutions. Real solutions are solutions that graphs would intersect. So you can solve this using a graph if you would like. I will show you both graph and hand. Graph first, hand second. On the graph, you want to graph the left side and the right side of the equation. You do not want to graph this. That's not allowed on the testing version of Desmos. So you have to graph 2 graphs, and you have to figure out where do they intersect. And it looks like I have a point popped up. You see that point right there? It looks like I have one value of X where they cross. Just click, 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 click. Look for a point to pop up that's not an intercept. Don't click on intercepts. Okay, that's not good. I don't see any other ones. So it looks like 2 is my answer. So it's always the X value. Now here's how you get the solution by hand. All right, first you're going to need to factor that X squared minus 9. That turns out to be X plus 3, X minus 3. That's a difference of 2 squares. So you have to know that factoring first. Next, you have to look at all your individual fractions or terms, I guess, and look for trying to get common denominators. This 1, that's just 1 over 1. So that has no denominator. You got to steal both the denominators, X plus 3 and X minus 3. Put them on the bottom and the top, just like when you're adding and subtracting. Over here, X minus 3, it has an X minus 3 that this has, but it doesn't have the X plus 3. So we're going to steal that and copy it to the top. This doesn't need anything with it because it has both the factors on the denominator already. The next thing we want to do is we want to just solve the equation on the numerator. So that'll be 30 plus 1, X plus 3, X minus 3 equals 5, X plus 3. Simplify the best you can. So we know X plus 3, X minus 3 was just X squared minus 9. So I'm going to rewrite that as 30. 1 doesn't really do anything. So plus X squared minus 9. And I'm going to distribute that 5. So 5X plus 15. This looks like it's going to be a quadratic. So we're going to get everything equal to 0. So solve for 0. So I'm going to subtract the 5X from both sides and the 15 from both sides. So as you can see here, I subtracted the 5X from both sides and the 15 from both sides. And I subtract the 15 from the negative 9. And the 5X didn't really have anything to subtract from. So that's just going to be a negative 5X. Now, these two numbers here also can combine. So 30 minus 9 is 21. 21 minus 15, that's all going to give you one number. So if I want to rewrite that, that's just going to be X squared minus 5X. And then 30 minus 9 is 21. 21 minus 15 is 6. So plus 6 equals 0. Let me bring that over here. This should be a factorable question. So X squared minus 5X plus 6 equals 0. We want to factor that or use technology if that helps. That's going to be what two numbers multiplied at positive 6 and add to negative 5. Can you think of those two numbers? Well, they're going to have to both be negative, aren't they? Because they have to add to a negative number. So I'm thinking it's going to be 2 and 3. Negative 2 plus negative 3 is negative 5. Negative 2 times negative 3 is 0. So that's my two factors. Therefore, my two answers, my zeros, would be X equals 2 and X equals 3, because we want to set each of those equal to 0. Now, I have two answers. The graph only gave me one. Why isn't the 3 giving me an answer? And that has to do with the restrictions. If you look at your denominator, you cannot divide by X or 0. So if -3 is plugged in or +3 is plugged in, that's going to give you 0. So those are those are not real answers. Those are considered extraneous solutions. So this is actually extraneous. So the only real solution, and this question wants to know what's the real solution, is going to be 2. And we got that real solution from the graph. The graph will not show you the extraneous solutions, but it will show you the real solutions. So you can write that down, and let's go into the next question. On this question, you know the drill. Again, it's best to kind of see if you can graph both sides and get an answer. As time consuming as these by hand are, it's to your benefit to save the actual time that you have for the ones that you don't have the ability to do Desmos graphs on. So I would graph the left side of that equation and the right side of that equation, and I would see where they cross. So pause the video, try that. When I do that, I click around and I'm looking for a point of intersection that is not an intercept. So that's no good. That's no good. We don't count those. But I do see a point over here. If I zoom in, that gives me an X value of 12. So 12 should be our solution. Let's see if that makes sense by hand. All right, let's put this out by hand. This equation is factored on the denominator, and it looks like, they all have an X -3 or an X. Now, a word of caution, this X is not the same as that X. X -3 is a separate factor from X. So you want to make sure that you have the exact same denominator, meaning that this X -3 needs that X to survive. And when you write it on one part of the fraction, you write it on the other part. So this is going to be X times X here as well to get those X's to be equivalent to 1. Over here, I need the X -3. So I'm going to copy that, and I'm going to copy X -3 next to 4. And just like that first fraction, I'm going to need an X on the numerator and the denominator to get those common denominators. From there, I'll have another numerator that I can solve. So if you think you can try this one based off of our last question, you can pause the video and give it a shot. In this equation, we'll have X times X plus 4 parentheses X -3 equals X parentheses X plus 3. When I distribute that 4 and the X, I'm going to get 4X minus 12 for this part, X squared plus 3X, and of course, X times X is X squared. The nice thing about this problem is that you have an X squared on both sides that would actually subtract and cancel out. So your equation is a little bit simpler to work with. It's just 4X minus 12 equals 3X. Now, if I subtract the 3X from both sides, let me write it up here, 4X minus 12 equals 3. If I take away 3X, I'm going to get X minus 12 equals 0. And then from there, I can just add 12 to both sides. And so there is no extraneous solutions. 12 was the answer that I got from the graph. 12 is the answer by hand. My restrictions, X cannot equal 3 and X cannot equal 0. So those don't really impact my answer. So that's question 3. Pause the video, write it down if you need to, and let's go on to the next question. All right, we're on part 3, number 4. This is another rational equation. We can try the graph again. Left side and right side, 2 separate graphs, see where they cross. If you want to do that yourself so you can be on the same page as I am, that'd be awesome. So I have the 2 left side and right side portions of my equation graphed. I'm going to find where they cross. And it looks like I have a point of intersection here at 2.8. Remember, we're looking for the X values. So I know that my answer should be 2.8. And one of these fractions would give you 2.8. Obviously, it's positive, so we can rule out the negatives. So it's one of those two. And if you do a little division, you can figure out that it's going to be 14 divided by 5 versus 14 divided by 9, which is going to be 1.555. So it's going to be 14 over 5. And that's a pretty simple one if you're doing it using a graph. So now let's go over how to do this by hand. This one is just a proportion. So you can actually just cross multiply here. So I'm going to just rewrite that as a cross multiplication problem. That's going to be parentheses 2x minus 3 times 4x plus 5. And that's going to equal parentheses 8x plus 1 times x minus 1. So if I do a little bit of FOIL, that's going to be 8x squared plus 10x minus 12x minus 15 equals 8x squared minus 8x plus x minus 1. Looks like I have an 8x squared on both sides. That'll cancel out. They'll subtract each other. And let's combine our terms. 10 minus 12 is negative 2, so negative 2x minus 15. Negative 8 plus 1 is negative 7. So negative 7x minus 1. I'm going to add the 7x to both sides to keep it positive. So let's do that. 7x. So negative 2 and 7 is positive 5. So 5x minus 15 equals negative 1. Finally, I want to add 15 to both sides, and that's going to give me negative 1 plus 15, which is going to be 14. So let me move that up here a little bit. All right, so 5x, 15 plus negative 1 is going to be 14. So I have 5x equals 14. And now you can see, oh yeah, x is just going to be 14 divided by 5 or 2.8 if you're doing a decimal. So there you go. All right, let's do a couple more, then we'll be done with this review. Pause the video, write it down if you need to. Part 3, number 5, EOC review number 4 is a word problem. Now, we have to be able to set up equations, of course, as part of our curriculum. Setting up equations, then solving them. So Kyle mows his lawn in 50 minutes. This is a work problem. How long is it going to take two people doing something together versus them individually? So Kyle mows his lawn in 50 minutes. That's Kyle. I'm going to go ahead and make a little Kyle diagram. He mows one lawn in 50 minutes. So we always put our job on top, how many jobs we have, and we always put our time on the denominator. So Kyle has one lawn in 50 minutes. Jeff helps him. They can get it done in 20 minutes. So we don't know Jeff's time, but the question, if you keep reading, it says, how long would it take for Jeff to mow Kyle's lawn on his own? So we don't know Jeff's time, but if I were to mow that one lawn, can we figure out how long it would take Jeff if we know that their combined times to do that one lawn would be 20 minutes. If Jeff helps them, they can get it done in 20 minutes. That's the both. So this is going to be the both, the combined. Sometimes it's multiple people, sometimes it's 3 or more. But regardless, you put your overall time here, and we're going to solve that equation. I'm going to call that x. So the equation is 1 over 50 plus 1 over x equals 1 over 20. There's several ways to solve this equation. You certainly can use a Desmos graph if you'd like. You can also just solve it by subtracting the fraction and doing a cross multiplication. So I could literally do 1/20 minus 150. Let's use the common denominator trick. So I'm going to do 50x 20. I don't have x or a 20 here, so it's going to be 20x. 20x. Here I don't have a 50 or a 20, so 50 times 20, 50 times 20. Here I don't have a 50 or a x, so 50x, 50x. So I have, it looks like on the numerator, 20x times 1, so 20x, plus 50 times 20. 50 times 20, of course, is, let's see, 5 times 2 is 10, so it should be 1,000, equals 1 times 50x. So your equation is 20x plus 1,000 equals 50x. If you want to pause that and try to solve it on your own, you can. All right, so I'm going to subtract 20x from both sides, and that's going to give me 30x. So my equation is going to be 1,000 equals 30x. Divide both sides by 30. And what do you get? Well, let's see, it's going to be 30.333, or 33.333. Yep, 33.333 minutes. So it takes Jeff to do that, 33.3333 minutes. So you can do that by hand, or you can do a graph. So write down anything you need from that, because I'm about to take it off and just show you how I can use a graph intersection to get my answer a little bit quicker. All right, you good? All right, let me take that off. I'm gonna show you. All right, folks, this is going to be 1 over 50 plus 1 over x equals 1 over 20. Notice that the right side was just the number, so we'll need a y equals. That's what your graph looks like. We know the answer was 33. If you go far enough here, if you click, you'll see a pop up 33.333, 0.05. That means the x value, that's what we're looking for. Pretty simple to do that way as well. So you got your choice, but you have to be able to solve that regardless. Let's do one more like that. All right, question number 6. Last question in this series of videos for review number 4. Part 3, number 6. A group of students are assembling care packages for the elderly. Morgan can assemble 2 of them in 10 minutes. Jordan can assemble 3 of them in 21 minutes. They need to assemble 20 total. How long would it take the 2 of them working together to do this? So in this case here, let's look at Morgan. Now she's not putting together 1 in this case, she's putting together 2. So her numerator is going to be 2, and it's going to take her 10 minutes. And as far as Jordan, well, Jordan can assemble 3 of them, and they can do it in 21 minutes. So it looks like I have both Morgan and Jordan's time. What I don't have are the combined times. But I know that we want to do 20 of them. So they need to assemble 20 of them. We don't know how long it's going to take them. How long, that's going to be my x value, is going to take both. So that's going to be 2 over 10 plus 3 over 21 equals 20 over x. Now, let me show you a different technique to solve that. I'm using a fractions. So maybe I want to just add 2 over 10 plus 3 over 21. And then I can click on this button here on Desmos, or if I'm doing a handheld calculator, I can do math enter. When I get 12 over 35. So that would actually simplify to 12 over 35. I'm going to rewrite that. As 12 over 35 is equal to 20 over x. And now I have a proportion, so we can cross multiply. So that's going to be 35 times 20, 12x. 35 times 2 is 70, so that should be 700. You can double check my work on that. And then divide both sides by 12, and you'll get your individual, or your time for 20 of them. So 700 divided by 12 is 58.33333, so about 58.33 minutes. And that is the combined time for Morgan and Jordan if they're both doing 20 of them in total. Now, in this problem here, I'm going to show you also on the graph, and then that'll be the conclusion of this. So write that down, and then I can show you the solution on the graph to back it up. Please write that down, because I'm going to take the work off now. Remember, the equation was 2 over 10 plus 3 over 21 equals 20 over x. So the left side is going to have all numbers. Put a y equals. You'll get your flat line. Go over here. Keep going until you click and you get a point, and you got a point, and I got a point. 58.3333333 repeating. My answer was 58.33 minutes. That concludes review number 4. Thanks for watching. The last review will cover all the stuff that we haven't covered yet, including a little bit of statistics at the very end. Stay tuned. Have a good day.